Well, here's another problem. It's very similar to number 11 in 3.2, the one I also made that video. So you're going to see a lot of similarities here, but I mean, let's just go through it. So we have, again, an integral with the square root of sine x, cosine cubed x dx. The last one was the square root of cosine x with the sine cubed x. So in this case, we're going to call this the u. You know, u equals the sine x, the part under the radical. And our du is going to be cosine x dx, which lets us rewrite this as integral of the square root of sine x times, think of it as cosine squared x times cosine x dx. So this part represents the du, and this is the u under there. So now we need to deal with this part, the cosine squared x. So as stated before, we go back to our trig identity, sine squared x plus cosine squared x equals 1. It's a Pythagorean identity in trig. So we're solving now for the cosine squared x, so we subtract sine squared x. I apologize to everyone who already knew that part, but then I'm doing this, kind of rederiving this property from trig. So we end up with this integral of the square root of sine x times 1 minus sine squared x times cosine x dx, which would be, if we do everything with the u substitution, integral of square root of u times 1 minus u squared du, excuse me, which is integral of u to the 1/2 times the quantity 1 minus u squared du. So that's going to give us the integral of u to the 1/2 minus u to the 5/2 du. And integrating that, it's going to be u to the 3/2 divided by 3/2 minus u to the 7/2 divided by 7/2 plus c. So it's going to be 2/3 u to the 3/2 minus 2/7 u to the 7/2 plus c. And as we use our improper grammar, what was u? 2/3 of sine x, and then, oh, I wrote that twice, to the 3/2 minus 2/7 of sine x to the 7/2 plus c. And that's it. Okay, hope that makes sense.